Okay, so see if you can figure out what our topic is today. Pause the video and take a look at the picture and see if you can figure it out. Our topic today is on Pythagoras of Stamos. Pythagoras of Stamos is a Greek mathematician that helped contribute to Pythagoras' theorem. Now, as you may have gathered, it has something to do with a triangle. This is a tetrahedron, or a triangle-based pyramid, but we'll be dealing with a specific type of triangle. And that brings us to our key words. Besides triangle, we need to be using our right angle. Okay. And then another key word is hypotenuse and converse. And our goal is through this lesson and our next one to learn how to use and apply Pythagoras' theorem. Today we're mainly going to be focusing on the using, and then later we'll be going more to the applying. So your first task is to see if you can write down the first 16 square numbers. So again, pause the video and give it a try. Okay, so you should have paused and tried finding the perfect squares by now. The perfect square is the answer after squaring something. So the answer to each of these 16 problems would be your perfect square. If you weren't sure about that, please go ahead and again pause the video and give it a try to find the perfect squares. You should have had 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. And you continue, 3 times 3 is 9, 4 fours is 16, 5 fives is 25. And by the time you're done, you should have each of these. Now let's say you only have up to 12 squared memorized. You always can use your long multiplication and do a problem like 13 times 13. 3 times 3 is 9. 3 times 1 is 3. And as this one digit is in the tens column, we need to start our multiplication answer in the tens column. So we put a 0 there. 1 times 3 is 3. 1 times 1 is 1. Add our values together, and we get that the product of 13 and 13 is 961. So 169. Okay, so we'll be using these because Pythagoras' theorem is going to be using perfect squares. So do make sure that you feel comfortable with them. Alright, the next thing we're going to try and do is identify the hypotenuse. So first we need to know what a hypotenuse is. If you think you know what it is, go ahead again and pause and write it down, and then see if you get it correct. A hypotenuse is the longest side of a right-angled triangle. Let me get that on the screen there for you. A right-angled triangle. There you go. And it is always opposite the right angle. So go ahead and sketch these triangles into your book and see if you can identify the hypotenuse correctly. Again, pause the video and then carry on when you're done. Okay, go ahead and check your answers. Those are all the hypotenuses labeled correctly. As you can see, following the instructions, they are opposite the right angle, which is the two lines that meet at a perpendicular or 90 degrees. So remember, lines that meet at a perpendicular, that means they're 90 degrees, and we call that a right angle. I have two problems here same problem, but Monica and James each gave an attempt at it. Monica labeled the hypotenuse below. Is she correct? Is this our hypotenuse? Why or why not? And James labeled his differently. Did he get it correct? Explain. Let's add that. Explain. Again, please go ahead and pause the video and see if you can explain the two of these. Okay, so it looks like Monica's gotten it correct. However, we don't know if the angle opposite is 90 degrees. So we cannot call that the hypotenuse because nothing has told us that this angle is 90 degrees. And you can't assume. We do, however, know that it is an isosceles triangle because that's what these dashes mean. So that those sides are the same length. And so if you have two sides the same length, you can drop a perpendicular, which is again a line that meets at 90 degrees, by bisecting or splitting it in half, and it will create a perpendicular with the side opposite it. So by creating this perpendicular, I then know that each of these are the hypotenuse of the little triangles that we've formed. So don't forget your other angle properties with triangles. So now that we've learned that there is a new side of a right angled triangle called the hypotenuse, which again is located opposite the right angle, and it's always the longest side, what is the theorem? Well, Pythagoras' theorem says that if you take one side and square it, and you add it to the square of the other side, you get the value of the hypotenuse when it's squared. So these would be my two sides. Now, oftentimes we use the letters A, B, and C. And you'll hear that a lot. A squared plus B squared equals C squared. Now, it's really important that when you're adding the two, that C in the formula is always your hypotenuse. So we're going to do an example, and then we're going to make sure that the letters don't trip us up. So our example, we have our right angle triangle, and I know that this is 6 centimeters, and I'm given that this is 8 centimeters. And they want me to find the hypotenuse. So I'm going to use the formula side squared plus side squared equals the hypotenuse squared, or A squared plus B squared equals C squared. And I'm going to substitute in one side, substitute in my other side, and set it equal to my unknown. Now, oftentimes with unknown, we use different letters, and as the formula usually uses C, I'm going to go ahead and use it in this case. Now, this is where our starter comes in. We've already said that 6 squared is 36, and 8 squared is 64. And I'm following BIDMAS, which is why I squared them first. Always follow your order of operations. And we get 100 is C squared. So the inverse of squaring something is square rooting. And by doing that, we're being left with just our C. And the square root of 100 means what times itself gives you 100. And the answer to that is 10. And a lot of people will give me that answer, and they've done a very good job on using Pythagoras' theorem. But you always want to make sure that you put your units in. So it'll be 10 centimeters as the length of our hypotenuse. So go ahead again and pause the video. Make sure you're feeling comfortable with that. And when you're ready to try some, go ahead and play. Okay, these are your problems to try. As you can see, I've written in the right angle. Please start by as always, identifying your hypotenuse and then give them a go. Once you've done trying them, go ahead and unpause the video to see how you did. Okay, so you should have identified your hypotenuse and substituted into the formula like I have here. If you did not, again, pause it and see if you can figure out where you went wrong and try and continue it from here. Square root of 3 is 9, plus 4 squared is 16, gives us our hypotenuse x squared. 25 is x squared, and to get x on its own, we use the inverse operation and square root both sides, which gives us that 5 is x. Now, as I didn't write units here, we wouldn't be writing centimeters because we don't know how long it is, but always double check and see if the problem had units. For number 2, 5 squared is 25, plus 16 is our y squared, because y is our hypotenuse in this case. 25 and 16 gives us 41. And then to get rid of the square, you use the inverse by square root. And we square root it. And, square root of 41. I don't remember seeing that in our list. And that's because sometimes our answers will not be perfect squares. So I can just leave it as the square root of 41 is y. Can anyone find my error? See if you can. Take a minute and see if you can find where Miss Butson went wrong. Hey, hopefully you saw that I identified the second side as 12, not 4. So when we correctly do this, it should be 5 squared plus 12 squared is our hypotenuse squared. If these were our two sides, this is the correct hypotenuse. However, that's not the triangle that we had. So 25 plus 144 is y squared. 169 is y squared. We square root because it's the inverse to get the hypotenuse on its own. And 13 is our y value. So even I make a mistake sometimes, especially with copying, that sometimes the error is that seeing the 12, it just became a 4 like the problem before it did. So hopefully you spotted that and questioned it. If not, don't ever be afraid to question what you see if you think that there might be something else that's correct. Now, I purposely didn't do this one yet And that is because we know our hypotenuse. If you correctly identified it, you should have said 10 is the hypotenuse, making Z and 8 are sides. When you know your hypotenuse already, instead you take the hypotenuse squared and you subtract the side you know squared. And that'll give you your unknown side squared. In other words, we just changed the way the formula is written. Because if I moved this over, I'd be adding it, because that's the inverse. And that would be the traditional formula we're used to. So my hypotenuse, since I know it, I'm going to use this form, 10 squared, minus our side that we already know is 8. And this is going to equal the side that we don't yet know, which is Z. Now everything else works the same. I'm going to follow BIDMAS and then use my inverse order of operations to solve. If you didn't give this one a try, why don't you pause the video now and do so. 10 squared is 100, minus 8 squared, 8 is 64 when you square it, equals my unknown side, which is Z squared. 100 minus 64 is 36, and we use our square root to undo or do the inverse of our squaring, which gives us that Z is 6. All right, please feel free to show my homework, send me any questions. Otherwise, give some work on solving using Pythagoras a try on your MyMath.